Bismillahirrahmanirrahim and Assalamu alaikum. My name is Ayan Rafiq and I am a foundation level student. And I will ask few questions and Maya will provide the answers. So let's start. So, hey Maya,
I'm all ears. Lay it on me.
Maya, my first question is what is software?
Think of software as the invisible soul of a computer. Well, hardware is the physical stuff you can actually touch, the screen, the keyboard, the silicon chips. Software is the set of instructions that tells that hardware exactly what to do. Without software, your laptop is just a very expensive paperweight made of metal and plastic. At its most basic level, software is just code. This code is written by humans in programming languages, which are then translated into binary and zeros that the computer's processor can incredibly complex recipe. If the hardware is the kitchen and the ingredients, the software is the cookbook that guides the process to create a specific result, whether that's a simple calculator app or a massive open world video game. We generally categorize software into a few main buckets. First, you have system software, like your operating system, Windows, Mac OS, or Android. This is the layer that manages the hardware and creates a platform for everything you actually interact with to get things done. Your world is housed in magnetic tapes, but now it's all hosted in the cloud, meaning it's not even living on your device and streaming the results to your screen in real time. It's the bridge between human intent and machine act for creativity, communication, and discovery.
So my next question is what is the difference between software and hardware?
The simplest way to look at it is the difference between the body and the mind. Hardware is the body. It's everything you can physically touch, feel, or drop on your foot. We're talking about the motherboard, the CPU, the RAM, the hard drive, the screen, and the casing. It's made of tangible materials, silicon, plastic. Once a chip is manufactured, its physical structure doesn't change. If you want a faster processor, you can't just shit into existence. You have to, physically swap out the old piece of silicon, hold an app in your hand. Software is the intelligence, the logic, the hardware purpose. Well, hardware is the what, software is the how. If hardware is a piano, software is the sheet music. The piano is a beautiful piece of machine. It tells the piano which keys to hit and in what order to create a melody. Another huge difference is how they change. Hardware is hard to update, really. Updating hardware usually involves a trimmer or a technician with a screwdriver, but software is fluid. It can be updated, patched, and completely rewritten overnight via download. This is why your phone can suddenly have new features or a different look after an update, even though the physical device relationship. Hardware without software is useless. It's just a heap of electronics. Software without hardware is a ghost. It has no way to manifest or execute its instructions, and the software provides the direction and the goal.
Okay, my next question is, what is system software?
System software is the unsung hero of the tech world. If we go back to the house analogy, system software isn't the furniture or the decorations, it's the foundation, the plumbing, and the electrical wiring. It's the layer of software that manages the computer's hardware so that everything else can actually work. It operates in the background, and for the most part, you aren't even supposed to notice it's there, which is actually a sign that it's doing its job perfectly. The biggest and most obvious example of system software is the operating system, or OS, whether it's Windows, Mac OS, Linux, Android, or iOS. The OS is the boss. It's the one that decides how the CPU allocates its power, how the memory is shared between different tasks, and how the hard drive stores your files. When you move your mouse or tap a screen, the OS is the translator that takes that physical action and tells the hardware exactly what it means. But it's not just the OS. System software also includes things like device drivers. Think of a driver as a specialized translator for a specific piece of hardware. If you plug in a brand new printer, your computer doesn't instinctively know how to speak printer. The driver is the piece of system software that tells the OS, hey, here is how you send a document to this specific model of printer. So it doesn't just print gibberish. Then you have utility software, which is like the maintenance crew. These are tools that help analyze, configure, optimize, or maintain the computer. Things like disk defragmenters, antivirus programs, and system diagnostics fall into this category. They don't help you write a novel or edit a photo. They keep the machine healthy so that you can do those things without the system crashing. Essentially, system software creates the environment. It turns a collection of circuitry into a functional machine. It provides a stable, predictable platform so that application software, the apps you actually use, doesn't have to worry about how the hardware works. Instead of every single app needing its own code to talk to the screen or the Wi Fi chip, they just ask the system software to handle it for them. Without system software, every time a programmer wanted to make a simple app, they would have to write thousands of lines of code just to tell the computer how to turn on the monitor. It's the invisible infrastructure that makes modern computing possible.
The next question is, what is application software?
If system software is the foundation and the plumbing of the house, application software is everything you actually move into the house to make it livable. It's the furniture, the appliances, the art on the walls, all the tools and programs designed to help the user perform specific tasks. Well, system software is there to serve the computer. Application software is there to serve you. At its core, application software, or just appses as we call them now, is software that is designed for a specific purpose. When you open a web browser to search for something, you're using an application. When you open a spreadsheet to organize your budget, or a word processor to write a letter, or a photo editor to touch up a picture, you're engaging with application software. There are a few different ways we can break these down. First, you have general purpose applications. These are tools that can be used for a huge variety of tasks. A web browser like Chrome or Safari is a perfect example. You can use it to read the news, watch a movie, check your email, or learn a new language. They're flexible and designed for a broad audience. Then you have specialized or niche applications. These are built for a very specific professional or technical goal. Think of things like AutoCAD for architects to design buildings, or specialized medical software that doctors use to analyze x rays. These aren't meant for everyone. They're high powered tools for people with a very particular set of needs. You also have the distinction between web based apps and native apps. The native app is installed directly on your device's hardware, like the calculator app that comes with your phone. It's fast and often works offline. A web-based app, on the other hand, lives on a server and you access it through a browser like Google Docs or Canva. You don't have to install them. You just need an internet connection and they handle all the heavy lifting in the cloud. What's fascinating is how application software has shifted our relationship with technology. We've moved from a world where you had one big computer that did a few things to a world where we carry a device in our pocket that can be a bank, a map, a movie theater, and a social club all at once, simply by switching which application we're using. Ultimately, application software is where the magic happens for the end user. It's the part of the machine that allows us to be creative, productive, and connected. It's the tool that turns the raw power of the hardware and the stability of the system software into something we can actually use to change our world.
Okay, my next question is, what is programming?
Programming is essentially the act of talking to a machine in a language it actually understands. If you think about it, computers are incredibly fast, but they're also incredibly literal. They don't have intuition, they don't understand nuance, and they certainly can't just figure it out. If you tell a human to make a peanut butter and jelly sandwich, they know what that means. But if you told a computer that, it would just stare at you because it doesn't know what a sandwich is, where the bread is, or what make even implies. Programming is the process of breaking down a complex human goal into a series of tiny, logical, unambiguous steps that a machine can execute without questioning. At its Wait,
My
you want me to
next
actually write?
Okay, my next question is, what is coding?
Coding is the actual
My question is, what is coding?
Coding is the practical, hands-on part of programming. If programming is the big picture, architecting, planning the logic, designing the flow, and figuring out the how of the solution, then coding is the actual construction work. It's the act of sitting down and typing the lines of text in a specific programming language to translate those plans into something the computer can read. Think of it like writing a book. Programming is the plotting, the character development, and the world building. It's deciding where the story goes and why. Coding is the actual writing of the sentences, the grammar, the spelling, and the punctuation. You can have a great plot in your head, but until you actually code it, until you write those specific lines of syntax, the program doesn't exist. When people use the terms coding and programming interchangeably, they're usually close enough for a casual conversation, but there's a subtle difference in scale. Coding is more about the language, making sure you put the semicolons in the right place, using the correct brackets, and following the rules of the language so the computer doesn't throw an error. Programming is about the problem solving, thinking through the logic and the structure to make sure the app actually does what it's supposed to do. It's the bridge between a human idea and a digital reality. You start with a thought, you program the logic to make that thought a reality, and then you code that logic into a language like Python, Java, or C++, so the machine can execute it. Does that distinction make sense, or do you want to dive deeper into the languages themselves?
The next question is, how is software developed?
Developing software is a lot like building a skyscraper. You don't just start stacking bricks and hope for the best. You need a blueprint, a foundation, and a very disciplined process. In the industry, we call this the software development life cycle, or SDLC. It's a structured roadmap that takes an idea from a random thought in someone's head to a polished product on your screen. The first step is planning and requirements analysis. This is the what and why phase. Before a single line of code is written, developers and stakeholders sit down to figure out exactly what the software needs to do. Who is the user? What problem are we solving? If you're building a ride sharing app, for example, you have to decide, does the user need to see the driver's car in real time? Do they need to be able to split the fare? If you miss a requirement here, you might build a beautiful app that doesn't actually solve the problem. Once the goal is clear, you move into the design phase. This is where the architecture happens. This isn't just about how the app looks, which is the UI or user interface, but how it works under the hood. This is the UX or user experience design. Developers decide how the database will be structured, how different parts of the software will communicate with each other, and what the overall logic flow will be. It's essentially the blueprint for the entire system. Then comes the part we've talked about, implementation or the actual coding. This is where the developers take those blueprints and start writing. Exactly, the process. This is the heavy lifting phase. The developers take the blueprints and start typing out the actual code in the chosen language. They build the features one by one, turning those abstract designs into working functions. But they aren't just writing a giant wall of text. They usually work in small chunks, building a piece, testing it, and then moving on to the next. That leads us directly into the most critical part, testing. You never just release software the moment the coding is done. That's how you end up with a disaster. This phase is all about trying to break the software. Quality assurance engineers look for bugs, those little errors in logic or syntax that cause that app to crash or behave weirdly. They run the software through every possible scenario to make sure it's stable and secure. If they find a bug, it goes back to the developers to be fixed and then it's tested all over again. Once the software is polished and the bugs are squashed, it's time for deployment. This is the launch day. The software is pushed out to the servers or the App Store, and it finally reaches the actual users. But it doesn't stop there. The final ongoing stage is maintenance. Software is never truly finished. As soon as people start using it, they'll find new bugs, or the world will change, or users will ask for new features. Maintenance is the process of releasing updates and patches to keep the software relevant, secure, and running smoothly. So it's a full circle. You plan it, design it, build it, test it, launch it, and then you keep taking care of it. It's a constant loop of improvement. Does that give you the full picture of the journey from idea to app?
Okay, my next question is,
What's
what
next?
does a software developer do?
A software developer is essentially a digital problem solver. If you think of a piece of software as a complex machine, the developer is the person who designs, builds, and maintains that machine. But their day to day isn't just typing code into a black screen like you see in the movies. It's actually a huge amount of critical thinking and translation. First and foremost, a developer's job is to translate a human need into a technical solution. A client or a boss might come to them and say, I want a way for people to order pizza from their phone and track the driver in real time. The developer doesn't just start coding, they have to ask 100 questions to figure out the logic. How do we handle payment? What happens if the driver loses GPS signal? How does the restaurant get notified? Once the logic is mapped out, they move into the construction phase. This is where they use those programming languages we talked about, like Python, Java, or JavaScript to build the actual features. They write the functions that make the order button work and the logic that connects the user's app to the company's database. But a massive part of the job, and this is the part people forget, is debugging. A developer spends a huge portion of their time being a detective. They'll run a piece of code, it'll crash, and they have to hunt through thousands of lines of text to find the one misplaced semicolon or the one flawed logical step that's causing the whole thing to fail. It requires a lot of patience and a bit of an obsession with detail.
So we will, this is the session, but we will meet to another my session. तब तक के लिए अल्लाह हाफिज़, पाकिस्तान जिंदाबाद.